Today I'll start organic chemistry, reactions and preparations for class 11 syllabus, that is alkene, alkane. General formula CnH2n plus 2, naming C, if you put n is equal to 1, that is C1H2 into 1 plus 2, that is CH4. This we have discussed in my earlier videos, how to name it and how we have done the isomerism and all. Today just we will discuss the reactions of alkanes or preparation of alkanes according to class 11 syllabus. That means a bit higher one. So firstly we will start with preparation of alkanes. First one is aluminium carbide. Now this reaction we haven't done in class 10. Aluminium carbide. Aluminium carbide formula is aluminium plus 3, carbon minus 4. So it is Al4C3. Hydrolysis with aluminium carbide. Now in this hydrolysis, how can we break up this water is HOH. So AlOH whole 3 plus CH4. Now H goes with C and OH goes with aluminium. See, aluminium is positive. This H is plus and OH is minus. Aluminium is positive, so OH is minus. So aluminium goes with OH and H plus goes with C. So we get CH4. Now is to balance it. 3 CH4 and 4 aluminium hydroxide. This is one of the preparation of alkanes. There are many more preparations. We need to clarify that. First one is this from aluminium carbide. Then we will do decarboxylation. This is number one. Number one is hydrolysis of aluminium carbide. Aluminium carbide. Then number two. Number two, we will do decarboxylation. As I have told you earlier, that D means minus and carboxylation means carboxy means carbon dioxide. Means carbon dioxide will be removed. So where from? Like if we take CH3COONA plus NaOH. Now we see that this way this carbon dioxide comes out. Decarboxylation of sodium salt of fatty acids. Decarboxylation of sodium salt of fatty acids. Now we will see that this will be CH4. This CH3 and H will give us CH4 and this one give us Na2CO3. Another reagent we have to add here is calcium oxide Often we term it as soda lime heat. This is soda, this is lime, and this is heat. So if we do it with soda lime heat, we will get it methane plus CD. Then the part 3, reaction 3. Now reaction 3, we can do it with Grignard's reagent or Warge reaction. Let us take Warge reaction. Very vital this Warge reaction is. We can take it as CH3Cl plus sodium in dry ether. See, we will take 2 sodium atoms and 2 CH3Cl atoms. We get it as this way. If we write it in a little another way, like ClCH3, so we will remove this in this way and CH3 and CH3 attached. So it is ethane. We have taken here methyl chloride. So we will get NaCl. Now this Warge reaction, with Warge reaction we cannot prepare methane because we have to start with methane only. So with Warge reaction we can prepare double membered carbon. So if we start with methane we will get ethane. If we start with ethane we will get butane, this way. Even mixed alkanes also can be prepared. How mixed alkanes can be prepared? How the mixed alkanes can be prepared? Mixed alkanes are like this. If we take CH3Cl plus 2Na plus ClC2H5. So here we see that CH3C2H5, that is we are getting propane plus 2NaCl. Clear? Next we will move on to coal-based electrolysis reaction. This 1, 2, 3, then we will move on to number 4, that is coal-based electrolysis reaction. Coal-based electrolysis. What is this? We can take CH3COOK. This is potassium acetate. Potassium acetate. We can say it as potassium acetate or we ethanoate. So, if we do like this, then how this will go? This is electrolyzed as, we have studied electrolysis in class 10, CH3COO minus plus K plus. So, if like this we can get two molecules of this, CH3COO minus, that means at anode we can say CH3COO 1 electron plus electron, and this at cathode this K plus will take up 1 electron, this will be K. Now this CH3COO dot, this is a free radical. So if we take two such CH3COO dot, what will we see is that the dot comes here. That means we have CH3 dot, so 2 CO2 and 2 CH3 dot. So this will be CH3 bond CH3. So it is 2 CO2. So it is ethane, coal-based electrolysis method. Okay. Next, we will move on to Grignard's reagent. How can we prepare alkanes from Grignard reagent? How can we prepare ethane or alkane using Grignard reagents? So next one is from Grignard reagent. Now, what is Grignard reagent? A preparation of this Grignard reagent. Preparation of Grignard reagent. Grignard reagent is actually alkyl magnesium halide, that is CH3 MgCl, or we can write it as CH3 MgBr or CH3 MgI. Generally we take Br, this one. Now, if this is the one product, then we can react it with water. CH3 MgBr plus water. So what will it be? Now water, as you know, we have done it with HOH minus. So this MgBr will take up this OH. So we will get CH4. This MgBr goes with this. So it is MgBrOH, magnesium hydroxybromide and methane. So this is the way how can we prepare alkane from Grignard reagents. Now these Grignard reagents, one of the most important reagent in organic chemistry. Later we will see it. Next we will do preparation of alkanes from any other carbonyl compounds. Preparation of alkanes from carbonyl compounds. What are these carbonyl compounds? Carbonyl compounds means compounds containing C double bond O group. That means aldehyde, ketone and acid. Acid you cannot say properly, but you can say it because it is containing C double bond O. Now suppose we have CH3CHO. So with this we should reduce it, you see, CH3 C double bond O H. We need to remove this O with 2 hydrogen. We must use here a reducing agent. That is, we must use red phosphorus HI. Red phosphorus HI. So this will supply our hydrogen, this one. So what will we get is CH3CHHH plus H3PO4. Sorry, H3PO3. Red phosphorus plus HI plus iodine. So this will be H2O plus iodine. See, this is HI. This H are supplied here, and this O comes with H to give water, and iodine becomes again I2. This I becomes as I2. This H is supplying here, means it is replacing these 2 bonds with 2 hydrogen. That's why we are getting CH3, CH3. Like this, we can do it with any ketone. Like this, we can do it with any ketone. Here also the same reagent, red phosphorus HI. So we will get CH3 again this O and this hydrogen. CHH. See here double bond O. Since here is double bond, so here is one O. And if we remove this, we should add two hydrogens. So we get CH3, CH2, CH3. That is propane. And the side products H2O plus I2. Similarly, we can do it with CH3COOH. That is acid. The same way, but here the reagent is required a little more. 6HI. 6HI plus 6HI because here it is OH, so we will get CH3 CHHH. 3 hydrogen here. So 3 from 6HI, so we will get this H2O and I2. 3I2. And we can take alcohols also. That means CH3, CH2OH. This is not a carbonyl compound, but still we can use it. Red phosphorus HI. Here what will happen? This OH will goes off and we will get a hydrogen instead. So we will just get one hydrogen. CH3, CH2, CHH, H plus I2 plus water. So this is another method, and we'll do another method that is called Clemenson reduction. This is very important, that Clemenson reduction. Clemenson reduction. The previous one also reduction, this is also reduction. Clemenson reduction, we will take same thing, CH3CHO plus, we should use here zinc, mercury, amalgam and concentrated HCl. So that we'll get that nascent hydrogen and it will substitute that oxygen. CH3, CH, okay, we will get plus H2O. In this way, if I take here R, means any alkyl group, so that will form that R CH3. Understood? So starting from acetaldehyde, we are getting ethane. Next, this is one, then we can do it with ketone. Similar way, zinc concentrated HCl. So we will get CH3. Again this O cut, we'll get 1H and get CH3 plus H2O. Then this is another, there is another reaction called pyrolysis. With pyrolysis also we can get alkanes, but that we'll discuss during alkenes, okay? So we will move on to our next part, reactions. Reactions of alkanes. Now we very well know that alkanes give substitution reaction. Alkanes give substitution reaction. So must sub. First one is halogenation. So we will take CH4 plus Cl2. That will give sun in presence of sunlight. This will get CHCl. This one hydrogen is substituted with one chlorine and this hydrogen comes here and that will give you HCl. This is the way this is going on. So it is CH3Cl. Again if you take CH3Cl and chlorine, so then this second hydrogen will be substituted. This is called dichloromethane. Dichloromethane. And again if we take this, so we will get it is as trichloroethane. So we get dichloro, monochloroethane, dichloroethane, trichloro and finally tetrachloro. So that will give tetrachloro. This is CCl4, that is carbon tetrachloride. And next, this is with chlorine, with bromine also similar way, but with iodine, this does not happen because iodine is a slow reactor. Iodine, the size is much bigger. We know iodine size is much bigger. So iodine cannot be done with this. And with for iodine we will do CH4 plus iodine. This will give you CH3IHI, but it must be carried out in presence of certain oxidizing agent. Then it will give CH3I plus H. Otherwise it won't give. And with fluorine also CH4 plus F2. This is very violent reaction. Direct chlorination is not possible because of explosive nature. Because fluorine is explosive, therefore direct fluorination is not possible. So next we will move on to next reaction, combustion, complete combustion, catalytic combustion. What is combustion? Combustion means burning with air. Combustion, the word itself indicates burning with air. Combustion, that means burning in air. Remember this is a chemistry term, combustion. We often say this, but you can't understand. That's why the meaning, burning in air, that is CH4 plus O2, it is CO2 plus H2O. See, carbon goes with oxygen will give CO2 and hydrogen goes with oxygen will give water. This is so simple. Now, if you take any other, suppose C2H6, that will also give the same reaction CO2 and H2O. Now, the balance you should do yourself. This here will be 2, here will be 2 plus 4. 4 oxygen, that is C2O2. This also you can balance and so on. Now the question comes, if this is excess air, in presence of excess air. Now if we give it in limited air, CO plus H2O, this will give CO plus H, very limited air, very limited. That will give simply carbon, like shoot. This will happen in case you are we making kajal like this. If we take oil and take a plate and hold it on flame, that will give you that shoot. That is formed like this because oil means hydrocarbons. Any type of oil is this alkane hydrocarbons, that any type of hydrocarbon will burn in air, but since we are keeping a plate over the flame, air supply is cut, it is very less, so we get carbon or soot. Next, let us move on to catalytic oxidation. Our alkane is very stable compound. It does not want to give any such reactions. It's very less reactions. So now we need to do catalytic oxidation. Catalytic oxidation. K2Cr2O7 plus H2SO4 HC. At first we will get CH3OH. The next step is HCHO. See, as we go on, the number of hydrogen atom decreasing, so it's more higher oxidation state. And the final one is acid. HCOOH. The final one is acid. Okay. Next we will move on to oxidation by KMNO4, tertiary butyl alcohol, and then finally isomerization. Isomerization is another process like this. This catalytic oxidation, then isomerization. Means it will form an isomer. What is that? Suppose we take butane. Then we use AlCl3 HCl 575K. So this will isomerize. How? CH3, CH2, CH3, CH3. This is butane, and this one the isomer of, so it's isopropane. Okay, isomerization. Then we can do aromatization with this also. Aromatization.